All right, guys. So, right, the last few days we've talked about one-step equations. Little twist, but the same steps over and over again. Today we're going to two-step. All right, and what you're going to see is you're going to pretty much see it's very, very similar to before. When I've told students that it is pretty much twice the work, but not twice as hard. Okay, so a lot of people go, oh, twice the work, that's twice as hard. It's not, the difficulty level is going to be the same. All right, so it's just a little extra twist in it. You'll have to write almost twice as much, but that's why there's only like half the problem. So you won't have much more work to do than usual. All right, so with that said, we do have vocab. All right, and it's only one, so when most of you guys already have green on the left, notes on the right, that is a two-step equation, everyone. Two-step equation. All right, so this is an equation having two different operations. An equation having two different operations. Okay, in your little box, go ahead and, this is an example of what a two-step equation looks like. So some people realize, and they say, well, Mr. Wilkins, and this happens occasionally, they say, well, I'm looking at that, there's only one operation there. So let me just remind anyone that was thinking of that, because that's a common mistake. You have your addition, that's probably more than likely what we see. But don't forget that x is being multiplied with the 2, with that coefficient. So there's multiplication there as well. So that's why there's two different operations that are involved this time. Okay, so we're going to do problems like this, so let's go ahead, and that is it for vocab, so you can put your binder away. Go ahead and grab your book, flip over to page 472. Okay. On page 472, problem number 2. Let's take a look at. I'll go ahead and write it up here. It's negative 3y minus 5 equals 10. All right, here we go. Step 1. Okay, put a little star by step 1 because step 1 is very similar to step 1 in the last 3 lessons, except there's one slight difference, okay? With a two-step equation, what we're going to do is we're going to find what I call the variable term. And what that is it's the term that has the variable in it. And that is what we're going to box in. So in this case, here's our variable, but the negative 3y is our variable term. Now that serves two purposes. One is it tells us, of course, which side of the equal sign the variable's on. And two, if you box it in, whatever's not boxed in is going to be what we're going to eliminate by doing the inverse. So we have minus 5 here. So here's what we do. Step 2 is we're going to do the inverse right there. It's usually, not all the time, but at least in 7th grade, a lot of times it will be additive inverse. Okay, so we have minus 5, so we're going to go ahead and add 5. Of course, whatever you do to one side, we do to the other. So if we add 5 to that side of the equal sign, we add 5 to this side. So those cancel. We end up with what is left here is negative 3y, and of course this is all step 4. We're going to simplifying our expression here, or what's going to be left over, our equation. Negative 3y equals, and then 10 plus 5 gives us 15. Now I'm going to make this easy. Instead of going this next round step by step by step, here's what I'm going to do. Step 5, we are going to do everything we've been doing the last few days, and I'm going to remind you that this is now all the steps that have to go with a one-step equation. And that's what that is, a one-step equation. So we go ahead, and I'm going to find our variable, box just the variable in, because that's what we've been doing. This time around, especially in 7th grade, it's going to be multiplicative inverse. We're going to go ahead and do the opposite of multiplication. Remember, it's only one inverse. It's division of -3. And whatever we do to one side, we do to the other side of the equal sign. I'll divide this side by -3. Right? Wherever we do this inverse here, they cancel. We end up with y equals, and then 15 divided by 3. Well, 15 divided by 3 is 5, but this is a positive divided by a negative. They're different signs, so we have our solution of y is equal to -5. Okay, guys, questions? So you guys probably get a good idea what I meant by it's not much harder, right? It's just kind of almost like repetitive steps. You do the first 4 steps, you do them again. All right. The only difference, of course, is what you are eliminating. Okay, on both of these. That's about it, though. Okay. Now, I do want to point this out. Okay. A couple of things that are very important. Make sure that we're boxing in the variable term. That's why we put the star up here. Because if you a lot of times people box in just the variable, and then they divide both sides by -3, and it affects the whole problem. So it's the variable term first. Okay. And then the other thing is if you take a look, the larger that your equations get, the more of a funnel look your work is going to have. Okay. Kind of an upside down cone until you get your solution. All right. So make sure you keep working downwards. A lot of people will do like the first part, and then they like go over and start doing the rest of their work all over the place. Stay organized, okay? Because as these things grow and grow larger as you get older, okay, and you move through your math classes, they're going to get larger. You're going to need more space, and you're going to have to get good at working downwards. Okay. Any questions? I'm going to have you try one. Here we go. Go ahead, grab your book. Just move over to the next page, 473. And try out problem number 5. Problem number 5. Go. All right, how many of you need more time? Okay, all right, check in with you guys for about 20 seconds or so. Okay, anyone need more time still? Okay. Okay, So we've talked over the last few days about all the different important things I want you to check with your partner, okay, besides, of course, the solution. But I want you to focus in on two things, and I kind of talked about them a second ago. When you look at your partner's work, please make sure that they have boxed in their variable term the first time around, not just the variable. And please make sure they continue to work downwards, kind of giving it that upside down cone or that funnel look, okay? So solution, and then check those other two things. All right, that's kind of your focus right now. So 30 seconds, turn to your neighbor and share. Go.
Mr. Wilkins?
Yes.
Do I turn this in now?
Yeah, thank you.
Okay, so first I boxed in my variable term, and then I started doing the inverse from -4, and if I do it to one side, I do it to the other one. Then I did 8 plus 4 equals 12. I brought down the boxed in term, and then I did the normal way of solving it, and got W equals -3.
Very good explanation. So I'm going to see if
He said, like, on the first thing that you need to do is that you need to box in your term.
like the whole thing or just the
Just the variable term. And then you need to do the inverse. So then after you do the inverse, it's -5 and positive 5. And you need to do this to this side.
these cancel out?
Yeah, it's 15. And then you bring down the...
Okay, guys.
bring down the negative.
I do appreciate all of you guys helping each other out, and I know all of you guys that are talking are still on task. That's awesome. Okay, I'm not mad at anybody for that. You're doing a great job. But because of time restrictions, I'm going to pull us back together. All right, and those of you that were kind of listening, just watch and see if you can't catch what your partner was telling you. And then if you don't, then ask a question about it. Okay. All right. So here we go. Problem number 5. Let's talk about solutions first. All right. See what's an example of a solution. So let's try seat 36. 36. Yeah, what was your solution? W equals -3. All right. Agree, disagree with that. What do you guys think? All right. Okay. Anyone else have another solution that they'd like to share? All right. Well, let's check it out. So we have, I'm going to go over here. All right. Number 5 was -4W minus 4 equals 8. All right, here we go. So, taking a look here, right? Box in our variable terms. So you should have boxed in your -4W. Step 2 was whatever's on that side of the equal sign we get rid of by doing the inverse. Of course, this is -4, so I'm going to go ahead and add 4. Step 3, do the same thing to the other side. So I'm going to add 4 to this side. I'm going to go ahead, these cancel out. I end up with -4W equals 12. Of course, that was step 4. Step 5 is now, I just finished it off with my one-step equation skills. So that means I just box in just the variable this time. It's being multiplied with -4, so I divide only one inverse. There it is. So that means I keep -4. I divide by -4 here. Whatever I do to this side, I do to this side. Those cancel. W is equal to, well, let's see, 12 divided by 4 is 3. Positive and a negative, so it is -3. So well done, guys. Those of you that had the right answer. Okay, questions on that one? Okay. All right, we're going to go ahead. Okay, question?
So first, like the -4 turns to +4, and then the bottom one is like stays the negative. But so isn't like first you always have to change it, and then the second time you don't change it, right?
It's not about first and second. It's, remember this part, when you have a coefficient, the whole point is that it's multiplication. That's your main operation going on here. So you want to do only the inverse of that operation. So you're not changing the -4 to a +4. You're only changing the multiplication with the division. And that, so like when we talked about one inverse, that's the main one right there that you're looking at. Okay, is that multiplication to division. So I mean, if you want to remember it as anytime you have a coefficient like that, it's always division. But you never get rid of the negative, it's a negative. Okay, or if it's a positive, you never turn it to negative. Okay. Does that help? Does that answer it? No? Yeah? Okay. Take some practice. That is a challenge for some people, guys. That's why I always talk about that. Okay? So don't be scared to ask if you come across that and you still are struggling. Okay, any other questions? Okay, this next problem is a two-step equation. Now we're going to, now difficulty level is going to be turned up a notch. All right, so here we go. Let's go ahead. Let's go back to page 472, and let's take a look at problem number 3. Problem number 3 is -7 equals 1 plus 2/3 n. Okay, now, I'm not going to bother writing steps because these steps are the same as these. Okay? But I just want to do one of these with you because what this is this is today's lesson mixed in with yesterday's lesson, or for you guys, of course, 2 days ago. All right? So, here's what I'm looking at. Step 1, box in the variable term. In this case, our coefficient is a rational number, meaning a fraction. So I box in our positive 2/3 n. Okay, step 2, right, is we do the inverse with what's on that same side of the equal sign. In this case, there's no sign in front of it, which means it's a positive 1. So I'm going to do the inverse. It's a negative 1 or subtraction of 1. Of course, whatever you do to one side, we do to the other. So, these cancel out. We end up with 2/3 n equals, and then -7 minus 1 is -8. Now, it's a one-step equation. However, it does have a rational coefficient. Okay? So here's what we do. We box in our n, right? Now, remember what we talked about yesterday or 2 days ago is that I could divide both sides by 2/3 because it's being multiplied with 2/3. But remember, instead of going through all that extra work, we're going to use our knowledge of KFC. Instead of dividing by 2/3, we're going to flip and change the sign, basically from division to multiplication. So we're going to flip. So instead of 2/3, we're going to flip it to 3/2, and we're going to multiply, which is the changing of the sign. So we're just going to multiply by the reciprocal. Whatever we do to one side, we do to the other. All right, so 3/2 and 2/3, that cancels, so we end up with n equals, and now this 3/2 times -8. Now, if you think that's -8, remember what I told you. Just you can put parentheses there to clarify it a little bit for yourself. Okay, 3/2 times -8, make it into a fraction. -8/1 makes it a little easier for many of us. Bless you. So, when I go to solve that, I can cross-reduce the -8 and the 2. I divide them both by 2. 2 divided by 2 is 1. -8 divided by 2 gives us a -4. And what we have when we multiply straight across, 3 times -4 is -12. 1 times 1 on the denominator is 1. Or simplified is n is equal to -12. All right. Questions on two-step equations with rational coefficients? Okay. Here's the problem I want you guys to try out. Page 473, number 6. Number 6. All right. Go. All right. How many of you need more time on that? Okay. I'll give you that time. All right, checking in. Anyone need more time? Okay, all right, about another 15, 20 seconds maybe. Okay. Okay, the main thing on this one is when you share your answer, but I also make sure that they're using multiplying by the reciprocal. One of the biggest problems people have been doing, I saw on whiteboards in the last couple of days, and I even, when I've been pulling sticks to have people explain to me what's going on, they will tell me that, oh, I'm going to multiply both sides by 2/3. Okay, right? That's not correct. That's not the reciprocal of 2/3. That, you know. So you can't just say, oh, I'm going to divide by 2/3. Instead, I'm going to multiply by 2. It's completely different, okay? So watch for that. Make sure it's a reciprocal, all right? Okay, with that said, 30 seconds. Turn to your neighbor and share. Go.
Okay, so I got b equals 49. I boxed in the variable term, and then I did the inverse, and then I got 1/7 of b equals 7. Then I did the reciprocal by turning 1/7 to 7/1, then multiplying 7 times 7/1 and got 49/1. And then I could reduce that to 40.
Yep, same.
All right, here we go. Problem number 6. You know what I was going to do over here? Maybe I'll just do it right here. All right. A little sloppy. All right, here we go. Problem number 6 on page 473 was 5 plus 1/7 b equals -2. So, very first step, right? Box in our variable term, which is the positive 1/7 b. Okay, I have a 5 here. I'm going to go ahead, that's a positive 5. I'm going to subtract 5. I'm going to do my additive inverse first. So I'm going to go ahead and subtract 5 here. Do the same thing to the other side. Those cancel. I end up with 1/7 b equals, and then -2 minus 5 is a -7. At this point, it's a one-step equation. I box in my b. I'm going to, instead of dividing by 1/7, I'm going to multiply by 7/1. I'm going to do it there, and I'm going to do it here. Those cancel, and we get our answer at b equals, well, this one, I can put -7/1 and say -7 times 7 is -49. 1 times 1 is 1, which of course simplified is -49 being our solution. All right, questions on that one? Okay, let's take a look at a word problem. Page 472, problem number 4. Okay, I'm actually going to flip the paper around and make sure I have enough room. All right, so problem number 4, let's close read it. It says, Cyrita wants to buy. Okay, sorry, that might be my fault. Let's go back. Let's try it again. Cyrita wants to buy some CDs that cost $14 and a DVD that cost $23. She has $65. Right? solve an equation to find out how many CDs she can buy. Okay? So, here we go. What we're going to do is we're going to use a bar diagram, but we're not solving it arithmetically like we did yesterday or 2 days ago. We're going to use the bar diagram, and I think in this class we actually solved it algebraically, and that's what we're going to do today. So let's go ahead and we build our bar. Okay, just to organize our work here, organize our expressions to make up our equation. Okay, step 2 is find out what is the total. Well, in this particular problem, the total, of course, is the total amount of money she has. All right, that total amount of money is $65. Now, step 3. Okay, step 3 is let's go ahead and write an expression down below, or at least let's come up with some information that splits this bar up to where we can write an expression and get an equation out of this. So in this case, with a two-step equation, you just have to realize that you're going to have a couple of things going on. And this is kind of the more common type of two-step equation. You're going to start with something that there's going to be a bunch of repetitiveness, because that's going to give you your multiplication, all right, with your variable. And then you're going to have what is like a flat fee. So if you remember right, on our Aunt Lulu's graduation party she was throwing, that's kind of what this is, right? It's very similar to that. We're going to write this expression. We have, remember for her it was the hall rental was the flat fee, and then she had to buy dinner for each person that came. She just had to find out how many people were coming, right? Well, that's the same with this. In this case, Cyrita, it says, wants to buy some CDs. We don't know how many, but what we do know about them that each of them cost $14. The very next sentence, though, says, and a DVD. That little letter, all right, with the A, that means that's saying one. There's one DVD, and that cost is $23. It's not a whole bunch of them, it's just one. That one DVD I can write down here. It might take up that much of our bar diagram. It's $23. Now, the other thing, though, is the DVDs each cost $14. So, if I wanted to break this up, look at, that's how much one DVD would cost. I'm sorry, CD. This is how much another CD would cost. This is how much another CD would cost. The only issue is I'm just going to put a ... because I don't know how many. That's actually the question. If you reread it, write and solve an equation to find out how many CDs. We don't know. But here's what I do know. If she bought 2, it'd be 14 times 2. If she bought 5, it'd be 14 times 5. It's 14 times however many she buys. So in this case, right, this is step 4. We're going to use this to write our equation. 14 times, we don't know. That's our variable. We don't know how many. However many CDs. However, what we do know is after we find out how many CDs, we'd have to multiply those and add on the regular flat number. All right? This bottom section, we've already said, is always equal to the top. Now, it does say write your equation. So here's your first answer. Then it asks us to find out the solution. So we're going to solve this two-step equation. Box in our variable term. I'm going to subtract 23 from there and from the other side to keep it equal. Those cancel. I end up with 14x equals, now this of course is 4 and 2, so 42. Now it's a one-step equation. I'm going to go ahead and box that in. It's being multiplied with 14, so I'm going to divide by 14 here and here. I get x equals, so you can punch that in your calculator if you want, but it is x equals 3. Now we can't forget about step 6, and that is just your normal in part on a word problem. Make sure you have your units. Again, it says write and solve an equation to find out how many CDs. It is 3 CDs. And there is our solution. There's our second answer. Now, before we end this lesson, here's what I do want to say. on here, you're going to have a problem that looks kind of like this. 2 plus 6n equals 5. It's not going to be exactly like this, but you might look at it and go, well, okay, Mr. Wilkins, that looks like anything else. Well, watch. When I go to solve this, I would box in my variable term, subtract 2 from both sides. I would get 6n equals 3, because those cancel. Then look at, box that in, divide by 6 here and here. This is not 2. This is not saying 6 divided by 3. This is 3 divided by 6. This is what it's talking about. So you have two choices, right? You can add a decimal point and get a decimal answer, or look at this. That is your answer. You just have to reduce. So you would get either 1/2 or goes in 5 times, right? Or 0.5, which are both the same meaning. So you can solve it either way. I'm okay with either way. All right?